Ladies and gentlemen, hello and welcome back once again to the briefing room. My name is Eric Cavanaugh and I will be your moderator for today's event, in which we're going to really check out one of the more interesting and compelling trends occurring in the world today. We're going to talk about embedded analytics. Is it the next big wave of innovation? Well, I can tell you that my partner, the esteemed Dr. Robin Bloor, was on the big panel on big data at the Enterprise Data World Conference just a couple of weeks ago in Atlanta, and he said flat out that he thinks embedded analytics represents the next big trend in this whole field of information management. So here is a slide about yours truly and enough about me. As many of you know by now, the whole mission of the briefing room is to reveal the essential characteristics of enterprise technology. If you are in the market to buy some of this technology, whether it be a data integration platform or an analytics solution or any number of things, quite frankly, then you want as much detailed, granular information as you can get before you make that decision. Because let's face it, even the inexpensive solutions in this market are not very inexpensive. And you want to make sure that whatever you buy is exactly what you thought you were buying. And you want to make sure it's going to do the kinds of things that you need done. So obviously a lot of that rests on you in the requirements gathering phase, but a lot of it also just requires you to do significant research. And so what we do here in the briefing room is we cover different topics every month, with the idea being that you can ideally get good apples-to-apples comparisons of vendors in a particular space. So June of the month is intelligence. Of course, we're talking about business intelligence, but also process intelligence, for example, and some of the other types of analysis that are done in the world of information management. Next month is disruption, then back to analytics in August. September's integration, of course, database and cloud, and then innovators will round out the year. So intelligence, boy, it has been a fascinating 10 years, hasn't it? We've really seen this whole field of BI grow from something that really only the biggest organizations could afford to do to the point now where it's pervasive. There are all kinds of BI solutions available to companies large and small. There are solutions just online, software as a service. There are hosted solutions. There are all kinds of different ways that companies can do business intelligence. And the topic for today is this concept of embedded analytics. So our speakers, one of which is John Myers from EMA Associates. He is actually right now at the TIA conference here in Texas, the Telecommunications Institute of America, and we're seeing some very interesting things going on in the world of telecom. Of course, they have lots and lots of data, and so getting a handle on this whole world of big data is proving to be a rather fascinating process. And I can tell you from our perspective, it's really interesting to watch and to learn how different companies are grappling with these huge amounts of data, and data not just like the structured data that we get in traditional business intelligence solutions, how many sales were made in this region during this time period, through this particular process, et cetera, but multi-structured data or unmodeled data is the way our partner Robin Bloor talks about this kind of thing. So helping you understand what you can do about this stuff is our goal here in the briefing room, and I will say that you can help that cause by asking good questions. So please don't be shy. You can ask questions either through the Q&A component of your webcast console, or you can chat them, and we'll also be checking out the Twitter stream for a hashtag of BriefR. That's B-R-I-E-F-R. Feel free to check that out. Analyst John Myers from EMA, very happy to have him here in the briefing room today. This is his first one. We have done, I think this is our 53rd briefing room, folks, and we only do them on Tuesdays, so you can do the math on that one. We started just about a little under 2 years ago, so almost every other Tuesday we do a briefing room. Very pleased to have John and his perspective. So Infobright, Columnar Database used for applications and data marts that analyze large volumes of machine-generated data. Infobright was one of the sponsors for our report that we just completed, and if you hop online to databaserevolution.com, you can find a link to that report. It's a comprehensive look at this fast-changing database market, and there are some very interesting things happening, folks. I can tell you that if you have not yet investigated how some of these new and or specialized database technologies can help your organization, it is definitely worth a look. because the old ways of doing things do not need to be adhered to anymore. There are new ways that you can address a whole variety of concerns out there in the world of managing data. So we're also pleased to have Susan Davis. She's the VP of Marketing at Infobright, and Susan is also extremely knowledgeable. She's been in this industry for quite a few years, and she's gotten her hands dirty on stuff. She knows what the nuts and bolts do, and we're very pleased to have her perspective today. So with that, I'm going to hand the keys of the WebEx over to Susan. And if you just click on that slide and then use the down arrow on your keyboard to move through, we'll be off to the races.
Great. It's an awesome responsibility, but I think I can do that. So thanks, everyone, for joining us today. You know, I've done a lot of these analyst briefings, but, of course, they're always or typically one-on-one and cover a lot of topics, so it's fun to be doing one with an audience today. So the word embedded, of course, has lots of different meanings to lots of people, but as far as how we're going to talk about it today, it really gets into this idea of moving analytics sort of back out to as far out as it can go. If you look at what's happening in the market today from a trend perspective, obviously the growth of the enterprise application markets continues to grow, but especially in the SaaS business, there's just more and more applications that today we're buying as cloud services or hosted services, and those are growing at very fast rates here. The big data challenge that everyone's talking about consists of really two different kinds of data that are outpacing your traditional corporate data. The first is what we call machine-generated data, and I'll talk quite a bit about that. And then, of course, you have unstructured, or as Eric said, Robin refers to it, unmodeled data. And these are really the two major components that are challenging people today in terms of the ability to capture and store and analyze and try and get value from all this information you're collecting. So at the same time, what's happening is as a consumer of these services or these third-party applications, the users are really demanding that I want to be able to analyze the data I'm collecting. I don't want to have to take it out. I don't want to have to export it into a central data warehouse. I want the application itself to provide me all sorts of tools and capabilities, not just to run reports, but to do investigative analytics, to drill down into my data, to really ask any question of the data that I want at any time. So one of these things that we've done is really cater to both technology, software developers, and SaaS companies who are looking to take advantage of this to add real competitive differentiation to their product or service by providing this kind of ad hoc analytics, this investigative capability to their customers. And so their requirements really fall into two categories. On behalf of their users and their customers, it's important to be able to deliver really fast access to the data. In some cases, what I would call near real time. And real time is another one of those phrases that has lots of different meanings, but you want to have access to your data very, very quickly, especially when you're talking about things like network analytics, for example, is trying to troubleshoot telecom networks, or web analytics, or other kinds of applications where data is just streaming in constantly, and I want the ability to analyze it, understand what's happening as quickly as possible. I talked a bit about ad hoc analysis and the capability to do that. So again, it's not just about I can look at a report and maybe I can change a few parameters, but I want the ability to start drilling down and asking questions I didn't even know I had until I started drilling into the data. So real ad hoc analytics is very important today. Obviously, high performance. One of the challenges that people also have with technology today is, can it keep up with the volume of data that I'm capturing? If I'm looking to store more history, or the volume of data is just growing at very high rates, which of course it is, can my database, can my tools keep up with it, so I don't have to sit here at my keyboard waiting 5 minutes till I get the response to a query I put in. I mentioned being able to keep longer data histories. You want to be able to look at things in context over time, so the answer you're getting to particular questions may not just be what happened 2 minutes ago, but for example, if you're looking at a web analytics, how does this visitor, what have they done before? What have they bought? What pages have they looked at, for example? Understanding that in the context over time. And certainly from a budget perspective, everyone is looking to do it with less, both in terms of less hardware, less effort, less DBA time, et cetera. So these are all the things that the customers of these SaaS vendors and the customers of technology companies are really looking to achieve. The technology provider themselves, of course, is looking to build in superior analytics so their products become more competitive. They're looking to meet all of the requirements in the left-hand box that their customers have. At the same time, they're looking for a way to reduce their database costs, because if you're looking at storing and capturing more and more data, you can't afford to have your database costs scale at the same rate as your data costs. People are also looking for a way to eliminate all of that DBA tuning that has been so traditional in relational database management systems for so long. Having smart software that really does it for you and takes the place of things like creating indexes and partitioning data and creating projections, et cetera. They're looking to minimize the hardware and software footprint, either if they're delivering an appliance, for example, that they can deliver a smaller hardware footprint, or if it's a software-only solution, how much hardware their customers would need to procure. And they're also looking for something that makes it much easier to implement into their own software and integrate with their application. So lots and lots of requirements that the underlying technologies to enable this analytics, a lot of requirements on the part of both the technology provider and their customers. So I'm going to do two things. I'm going to just run through a couple of case studies of customers of ours who are using Infobright for this purpose, and then I'll drill down a bit into the technology and then have a nice conversation with John today. So the first one I want to talk about, this is a solution that gets delivered to some of the world's largest telecom operators. JDS Uniphase is about a $2 billion company. They are one of the premier providers of communication services, solutions, instruments, system software that really help communication service providers, equipment manufacturers, and others implement new services, maintain their competitive edge, troubleshoot their applications, deliver the kind of service that their customers expect. And within this, one of their lines of service, one of their product lines is called their Service Assurance Solutions. And what this does is it is there to enable and ensure high quality of service for wireless voice, data, messaging, and billing. And as I said, it's used by many of the world's largest network operators. So within that, there is an application called Session Trace. And what Session Trace does, it supports a broad set of network protocols, including, for example, the latest 4G networks. And what happens is it captures all of the information that's coming in across the network. And I'll talk a little bit about how that was implemented. But the objectives that JDSU had for this project was to come out with a new version of this application that would support much faster load speeds. So they, of course, all the carriers that are their customers are seeing increasing call volume, and they're looking for really near real-time data access to troubleshoot their networks. They wanted to, at the same time, to be able to reduce the amount of storage by 5 times, but they also wanted to keep longer data history. That might seem counterintuitive. They were looking to reduce their overall database licensing costs. They wanted to eliminate what they referred to as the DBA tax, and this essentially meant that their customers shouldn't have to do maintenance or tuning of the database, while at the same time being able to ensure the kind of ad hoc analytics and drill-down capability that they were looking for. They needed to make sure that even as the volume of data increased, that their customers using the system were getting the fast query response they needed when they were troubleshooting issues, and they needed to support up to about 200 simultaneous users at some of the large carriers. So this is at a very, very high level, as you might expect. What the application looks like. You have data streaming in from a broad set of network protocols, as I said. It populates multiple database instances based on geographic regions, of which there are many for their carriers, depending on the regions that the particular carrier covers. So the application includes a web-based front end that passes the information to a query generator, which then sends the query to the appropriate database instance. Now, when you're talking about some of the largest network operators in the world, each geographical site might store between 6 and 45 terabytes of data, and the total data volume, as it says here, will range from about 700 terabytes to about a petabyte of data. So clearly we're talking about big data. Now again, I'm going to spend a few minutes in a minute talking about how Infobright works, but this is sort of a generic look at how an application of this kind of size and this kind of data volume is implemented in an Infobright environment. So you've got multiple sources coming in of the data. It is getting sent into software that we call DLP, the Distributed Load Processor. So each one of these is ingesting the data. I will talk a bit about what it's doing, but it's compressing the data, it's creating knowledge about that data, and then through the query engine, it is sending it off and storing that in the regional database, if you will. And then people can access that at the Network Operations Center through various devices. So by implementing Infobright and moving from their more traditional database, JDSU was able to achieve the objectives that they set for this project. They saw a 5x space reduction in terms of storage, and that is based on very high rates of data compression that our product offers, that I'll talk about in a minute. They were able to store 5 times more history online at the same time, which again becomes important when you're looking at what's going on in my network over time, and do I have particular problem areas that need to be addressed? Are there capacity constraints that I should understand based on looking at the data over a longer period of time? They needed to get the data in quickly, and their goal was to get in rates of 20,000 of these TDR records per second, which is about 40,000 database rows per second, and to append the data into the database very, very quickly. As I said, key goal also was to eliminate that DBA tax, so get rid of the indexing and manual tuning that other databases required, at the same time reducing servers and storage and reducing their licensing costs as well. So that is one example. Again, that is a delivered solution that JDSU provides that gets implemented within the carriers themselves. The other model, and we have quite a few of these, especially in the web analytics world, is a SaaS vendor. So Bango is one of the leading mobile payments and analytics vendors out there. Very, very interesting solution that they have. And here is just a little bit about it. There's obviously, I don't know how well you can see the information on this slide here. But they deliver this as a hosted solution. Their customers include many of the world's leading brands, thousands of content providers and developers, and mobile carriers. And what their analytics solution lets you do is track and analyze how users navigate mobile sites. It provides a very accurate view of visitors, their behavior, their engagement levels. And the key here is that it's not just the information about, for example, what websites you're looking at, what pages you're traversing, and what clicks you're making, but it enriches the data through Bango's partners, who include carriers and handset manufacturers and developers. So combining that telecom data with all that web data is what really enables accurate visitor identification and location information, including device, country, operator, and then they provide this information to their customers with a real-time reporting system with very powerful filtering for segmentation. Just a little off the track here a bit, but some of the challenges with things like, and the reason you couldn't do this, for example, with tools like Google Analytics, is they only give visibility to a small percentage of traffic when you're talking about mobile. So Bango service includes the kind of data collection, the campaign tracking from all of these networks and Wi-Fi, page tracking, and other services. And again, it provides back mobile-specific information to the advertisers, and all of this really enables their customers to better understand subscriber behavior, to optimize mobile marketing campaigns, to drive higher advertising rates, and all really within minutes of these transactions happening. And it's based on the richness of the data and the ability to personalize these kind of mobile ads, by the way, that click-through rates for mobile ads are about 10 times that of traditional online advertising. So as you might expect, lots and lots of data, near real-time requirements on their part of their customers to understand what's going on, because they're really trying to improve the ROI of their mobile advertising. So why Infobright? Well, what happened was Bango was using, their database happened to be SQL Server, which is a fine product, but as the amount of data that they were capturing increased, SQL Server really couldn't keep up from a query performance perspective. So Bango was looking for something that could scale, and as the data scaled, it could provide very fast query response. They could implement very quickly into their service and do in a low maintenance and a cost-effective solution. And they were pretty astonished. This is actually, these stats right here are from some time ago now, but this is the kind of increase in performance that you can get really when using the right tool for the right job. So with that, I'm just going to spend a few minutes going through and talking about how Infobright does this. But there's really sort of three key components of the technology. The first is that it's a columnar database, and I'm sure John and Eric and Rob and Belora certainly are very familiar with columnar databases. For those of you on the phone that aren't, I'll spend just a minute talking about what it provides. It's also about using intelligence about the data to drive performance and really having sophisticated intelligence under the covers rather than having administrators, DBAs go in and do things like create indexes and do tuning. So the idea about using intelligence about the data to drive performance instead of DBAs to do the work is what we're all about. So four key pieces from an architecture perspective. As I said, the first thing is that it's column-based. So when you think about data coming in, it can be stored in two ways. You can store it in rows, which is what most traditional databases do, or think Oracle or MySQL or SQL Server, or it can store it in columns as databases like Infobright or SideBySideQ do. And the advantage from an analytics perspective is typically what you're looking for is not every column of information. So if you're in a call center, for example, and someone calls in with a question, you want to look at all the information about that particular customer. So it's very well suited to a row database. But if what you want to know is, looking through my employees, how many do I have in a certain location in a certain department, well, I'm only interested in those two columns. So by organizing data in columns, it means you can bring back a lot less data, and therefore you're going to get much faster performance for queries. The next part here is that we use something called data packs. So as data streams into Infobright, as you saw in the case of JDSU, for example, it is stored in subsets of each column that are 64K information each. And what happens is each of those data packs is compressed, and the compression algorithm is actually based on the kind of data. So we get very, very high rates of compression. It averages about 20 to 1. At the same time as that data is coming in and as it's being compressed, Infobright is automatically creating and storing information about that data itself. So for example, if numeric data were streaming in and being stored in the data packs, it would automatically calculate information like the min value in that data pack, the max value, the sum of them, the number that it contains, the average, all that sort of information automatically gets stored into the knowledge grid. And it's almost as if every data pack within the system, every row and every column is being automatically indexed. And that information is used when a query comes in to eliminate the need to access data to respond to the query, because a lot of the information is already stored in the knowledge grid, which is loaded into memory. The other piece from a technology perspective is that our software is based on MySQL. MySQL is used largely because of the richness of its support of things like BI tools and programming languages. So whether you have an application that you're writing in Java or in PHP, or you're using a BI tool from MicroStrategy or Pentaho or Jaspersoft, for example, it's all supported with Infobright because of the interfaces that MySQL supports. In terms of how you get the data in, there's lots of different options, and it really depends on what the requirements are from an application perspective in terms of load speed. And in terms of what you're used to. So for example, if you're a current MySQL user, you can use a MySQL loader. The Infobright loader provides higher speeds, and then for the highest amount of data loading options, the distributed load processor, which I referenced before, we have tested to load speeds that can exceed 2 terabytes an hour. It also includes a Hadoop connector because we see, especially in the web analytics space, lots of people using Infobright with Hadoop. It's really very complementary technologies. You can also use some of the data integration tools from Pentaho, Talent, Informatica, et cetera. So again, just a quick summary. So what happens is this information about the data is created automatically upon load. It's stored in the knowledge grid, which is loaded into memory, and it's very, very small in size. It's less than 1% of the compressed data size. So when a query comes in, the query processing engine uses this information in the knowledge grid when processing a query, and it does it in an iterative fashion. And the goal of it is to use the information in the knowledge grid to eliminate or reduce the need to actually access the data to respond to a query. And the less data that has to be read back from disk, the faster the response. And in some cases, depending on what the query is, it may be answered entirely from the information in the knowledge grid, in which case you're going to get sub-second response to that query. And all of this at the same time without the need for the DBA work that traditional databases require. Again, as I said, there are no indexes to create or maintain. There's no projections. There's no manual tuning. This also means that ad hoc queries are as fast as static queries because I don't have to have planned in advance and tune my database for the queries I know someone's going to ask. Finally, because we're so focused on machine-generated data, as I mentioned, it's one of the 2 components of big data that's growing the fastest. So think of things that, whether it's web or telecom data or sensor data, it's all this information that is being auto-generated by a system somewhere very, very quickly, and has the characteristic that typically it's streaming in at very, very high rates, 7 by 24. So we have some really very interesting value add into the technology, which is specifically designed to enable great query performance and fast response for machine-generated data. The first thing is something we call Domain Expert, which has information about the data. So that is more than just, is it numeric, is it a character field, but it can actually understand what a URL is, for example, or it can understand what an email address looks like. And it lets users go in and define their own context, their own patterns in the data, which lets the query engine use that information, again, to speed up queries. I mentioned the distributed load processor and Hadoop, and then something very interesting that we did about a year ago called Rough Query, which is really very well suited, especially in telecom, that lets you instantaneously drill down into very large data sets. And it does this to help you really find a needle in a haystack. And it actually uses information in the knowledge grid to let you very quickly narrow down to where my data is. So instead of firing off a query, which has to go through and read, a billion records or something and will take a long time, it lets you very quickly, from an investigative analytics perspective, narrow down your search until you fire off the exact query and it comes back very, very quickly. So who's using Infobright? Well, we have a growing customer base across use cases and verticals. We have about 300 direct and OEM customers across the world today. About 1,000 installations from those customers, and the product today is being used by 8 of the top 10 telecom global carriers via our OEMs and our ISV SaaS companies. And you can see a list of who some of these customers are. And as Eric mentioned at the top of the hour, we have both an open source and an enterprise edition product, so we welcome you and encourage you to go download either the open source version, which is the full GPL2 version of our software. We have integrated virtual machines, which provide full BI stacks with companies like Pentaho and Actuate and Talent, for example, and Jaspersoft. And we have forums that we are proud to be very responsive to as people are trying to learn the products, or to go to Infobright.com and download a free trial of the Enterprise Edition product. We also have some really great white papers for people that are trying to make sense of things like row, column, NoSQL, Hadoop. We've got some white papers out there which are really meant just to be educational, not promotional, that will help answer some of those questions. So that was a mouthful. So at this point, Eric, I guess I'll turn it back to you.
Folks, we have some really, really good questions already coming in. Thank you so much for those. And don't be shy. Keep them coming. We will queue up the Q&A with about 10 minutes left before the top of the hour or so. And with that, I'm going to hand it off to John Myers. I'm going to hand you the keys. You've got them right now. So the floor is yours. Just click on that slide and use the down arrow on your keyboard.
Yes, sir. And Susan, that was some excellent information. We had talked not too long ago, and that was an excellent update on what I think is happening out there in the marketplace. So I'm going to start my kind of remarks in terms of embedded analytics, about talking about pushing analytics to the edge, so to speak. This is some information we've already covered about who I am, and if people want to get in contact with me, I was one of those few lucky people who got to get the same logo or the same ID across multiple platforms. So as long as I'm at least the 43rd person, I guess to have my name like that. When we start talking about big data, particularly in machine-generated data, the next big wave of it is going to be not just machine-generated when we're talking about in terms of telecommunications or web, where they have a great advantage and a wonderful kind of almost proto stage of the big data piece, where they're generating information off of network elements or from web servers or things of that nature. But we're going to move out into an area where we're talking about machine-to-machine data, where we're going to be pulling information from trains, planes, medical devices, washing machines, the tablets in the cars there are probably the closest ones to being into that. But each of these allow for a different type of optimization business model, and we're going to see information generated from all of these devices, all the way from, say, a medical device, which is giving information about heart monitor, about heart rate, blood pressure, things of that nature, to the washing machine example, where it's going to tell you how much water is it using, how much electricity is it using, what are these particular pieces of information. And it's going to give us a whole new definition of many-to-many. In Susan's conversation about telecommunications, in particular the JD Uniphase piece, we're talking about people managing their grids. Now let's talk about taking that information gathering and pushing it out to the edges of the grid or the network, if you will, to an enabled automobile or the wireless tablet or all of these different pieces of information. And we're trying to push all of that data gathering farther and farther away from, say, a centralized core. On the left-hand side, is how we oftentimes generally describe big data. We talk about it coming in these huge pipes and these things of this nature. When we talk about going to a machine-to-machine type of environment, it's a little bit more like what I'm showing here on the right-hand side, where we've got little trickles of rain, but that sooner or later that generates into a huge flow of water that then becomes the big centralization that we see on the left. But we're going to be talking about going from big data, which is large in and of itself, to lots and lots of files, and simply because of the platforms and the sources that we're getting the information from, it will explode to the sizes that we're seeing right now, or even greater. Now, how do you handle the response time? Today, we do a lot of the trucking around of the information using relatively large pipes that can get us to the point where we can get the information from where it's generated to an analytical core. Susan did an excellent job of showing that geographic distribution, which is kind of one of the first layers of trying to say we're going to continue to push it out. But when we talk about machine to machine, it's like, how do you handle like one little bucket of water going from point A to point B so that we can get that piece of information going through? And the way I take a look at it is, rather than putting the analytics in the center, and let's see if my little animation actually works. Nope, it doesn't. That the analytic is supposed to move out to the edge, but rather than doing the analytics where you have to take the data and take it from the edge to the center and back, why don't you push the analytics farther and farther down? Infobright's done a good job of showing how it's very important to be able to do that, because as you move away from that centralized core, you move away from some of the services, if you will, of the centralized data center. Susan made an excellent point about how Infobright lowers the cost of that DBA tax. When you are pushing out farther and farther to either in the network or even onto the devices themselves, you don't have access to those folks who are constantly tuning and tweaking. You need to be able to have technologies that allow you to do the analytics where they are, how they are, and have the machine be able to do the level of performance that you're looking for. And also, you may not know what the level of performance that you're looking for is going to be predefined. Columnar databases are a great way of when you can't or don't want to set a structure or a semantic layer in advance. It allows you to have that flexibility to say, I only want to look at these pieces today, but I don't want to throw the rest of it away because I may need those columns or those pieces tomorrow. And that allows you to have that flexibility to continue to move from the center, where we see centralized administration, centralized definitions, farther and farther to the edge where you're having a less fine-grained definition of those pieces. So I believe this is where we start our question and answer. Eric, I guess I will kick it back to you, but I want to thank Susan for teeing it up quite well. You know, Infobright is setting the stage for what a lot of those organizations, telecom, finance, et cetera, who are in those initial stages of the big data use cases to make their use cases better. And as we move forward and try to include machine-to-machine data, we're going to need to be able to have some more of those exact same traits being able to push farther and farther to the edge.
Okay, good. And you could just go ahead and start asking your questions directly of Susan. So you got the next 15, 20 minutes. Go for it.
Susan, as we were going through, I came up with some notes, and we've written them down in advance a little bit here. We talked a little bit about telecom and mobile payments being key use cases. What are some of the other types of use cases that Infobright is seeing? What are the top 5 that may or may not include those two?
Right. Well, certainly it's not just mobile payments. So I think one of the areas that we're seeing just the greatest adoption is all sorts of online businesses. So many of these are marketing services, marketing SaaS companies who are, of course, accumulating lots and lots of web data. So a good example, we have a customer named LiveRail, and LiveRail provides a platform for video advertising, which happens to be the fastest growing of the type of online advertising happens to be video. So really what they're doing, again, an interesting use case here is that people are adopting their product to do video ads, and their application keeps over, I think the number was like 1,000 metrics as people are watching these videos, things that you and I would probably never think about. But for example, when people pause a video, do they rewind it? Do they go back and watch from the beginning? How long do they watch? All sorts of stuff. So on behalf of their customers, who are advertisers and ad agencies and ad networks, they're capturing all of this information and then providing it in near real time back to their own customers to analyze the effectiveness of their video advertising campaigns. Because they are keeping all of the cookie-level data, they are actually using Hadoop along with Infobright. So they're taking all this cookie-level data that's streaming in, they're putting it into Hadoop, which is really well-suited to run sort of batch, long-running queries that can spread out over lots and lots of servers, and then they extract the key information and they provide it through a front-end portal to their customers. Bango, as I mentioned, that's mobile payments and mobile analytics. So lots of companies in that online space, mid-tier social networks, for example, gaming companies, but many, many around the advertising space, both online and mobile. So overall, probably 60% of our customers today are really in the telecom and some sort of online business.
Yeah, excellent. Yeah, over the last couple of years, the wider telecommunications industry, as it moves away from voice into that video content, whether it be through fiber to the home or over-the-top video or whatever their particular video choice is, I know that lots of them want to be able to crack into that behavioral aspect and kind of be able to divine who's sitting in front of the television so they can give the right ads to the people in real time, no matter whether they have time shifted it on a digital recorder or they're watching it on their PC. They want to be able to say, all right, who's watching it, how are they watching it, and in which way can we best get them the advertising that'll make it memorable to them.
Right. As a matter of fact,
without being intrusive, if you know what I'm saying.
Right. Yeah, social media analytics is a big upcoming thing. I sat with one of our customers a couple of months ago, and they're in that business where in response to either ads or events or other things going on, what their service does is it actually tracks all the social media traffic that's going on. So if one of their customers, for example, is Procter & Gamble, they know when those ads are on, where they're running, and they can actually track the social media traffic and Facebook and Twitter in response to that. So we're just at the infancy of that, but there's just been this huge explosion from a mobile perspective in all aspects, and now this social analytics is up and coming as well.
Yep. So my next question is, now you mentioned in your slides that you guys are across many different geographies.
Mm-hmm.
We at EMA have found that there are certain implementation models, say for North America, which are a little bit different than EMEA, which are a little bit different than Africa. Are you finding a particular adoption rate or is there a particular region where your adoption is growing, or are you pretty much equally distributed across those regions?
Well, I think that probably it really mirrors sort of the size of the IT industry in each of those cases. So, I think the U.S., North America is probably about 50%, Europe about 30%, and about 20% in Asia. We're really starting to see some good growth in the Asia regions, though, and the Middle East. So hotbeds of technology like in Israel, for example, because, again, so many of the companies we're selling to are technology vendors that countries and regions where there's a lot of that kind of activity are becoming adopters of Infobright.
Okay, excellent. We talked a bit about, again, the use cases of telecom and mobile payment as being sweet spots for Infobright. What are some of the key attributes of those data sets that particularly make it good for the columnar technology and the compression algorithms that you guys have to offer?
Right. Well, again, it really goes back to this concept of machine-generated data. And what those kinds of applications all have in common, again, is the fact that not only do you have a lot of the data, but it's streaming in all the time. So, and typically, while you can be doing some updates or deletes of that information, they really more resemble log files. So in most cases, the data isn't changing. So if you've got, for example, a transactional application, that would not at all be a good use for either Infobright or a Columnar Database. So they're really very well suited for analytics, where the data is really not changing particularly much, but it is, coming in at very high rates.
Okay, excellent. My next question is, you talked about your choice of MySQL, and you talked a little bit about the interfaces. Are there some other qualitative or quantitative reasons why Infobright made that particular choice to go with MySQL as opposed to either a proprietary query interface or something more like a PL SQL or something that's offered by another vendor?
Right. Well, I mean, MySQL is embedded into Infobright under the covers. We made that technology choice really when we started about 5 years ago. And I'd say there was a number of things that really attracted us to it. The first of which was one of the key values that we believe we provide is simplicity. So we wanted a database that would really be accessible and easy for people to access and to use. So we didn't want something that was going to require, lots and lots of administration. Now, part of that is what Infobright has built, but MySQL also was really sort of meant to be the database of the masses, if you will. The fact that it was open source, and so we have, again, both an open source version and an enterprise version of our product, so the business model fit very nicely. And again, really one of the key things is that it was important for us to have something that would really let people build their front ends using any tool, any programming language, any BI tool, without a requirement on us to continue to recertify with every one of those, because that's a very tough space for a technology vendor to be in if you've got interfaces and every time another piece changes somewhere, you've got to retest and recertify. That really doesn't work very well. So whether you want to write an application in C# or Java or PHP, or again, you want to use a BI tool out there, it really gives people the ability to pick the best of breed and do what makes the most sense for them.
Yeah, no, when you make that proprietary choice, oftentimes you get stuck in the limbo of change management, and you become
absolutely
a
right.
To, as you pointed out, conformance or compliance as opposed to really pushing where you want to be in other areas. We talked about big data in the presentation, and most people talk about it in terms of the 3 V's, volume, velocity, variety. What is going to be the Infobright's competitive advantage over other vendors, whether they be structured or unstructured? Some of my guesses are going to be the things you talked about: implementation cost, time to implementation, and load speed. But I wanted to hear what you had to say.
Yes, I mean, again, we're all about providing a product that is simple to implement, simple to manage and use over time, that is a lower cost solution, so both from a hardware reduction point of view because of very high rates of compression, the fact that we can support up to about 50 terabytes of data using a single industry standard server. So performance is key, but things like making it easy to use, reducing people's costs of doing business are equally important. So those are sort of the 3 key legs in the stool for why somebody would select Infobright over something else.
Okay. Recently, we've seen at EMA and when we talk to other technology vendors, I've seen kind of a trend for some of the row-based vendors to say, hey, we have columnar indexing, and it works just as well as using a purpose-built Columnar Database. I wanted to hear a little bit from you about where you see the differences are between purpose-built Columnar versus the Columnar indexing, which is becoming a little bit more popular these days.
Right. Well, I mean, I think that the reason some of those vendors have done it is because it does provide some query performance advantages, but it really doesn't provide you, I mean, I think the key message that I want to leave people with, and we talk about a lot, is, find the right product to match your particular use case. So one of the things at Infobright is we try and be really clear on where we're a good fit and where we're not. And if someone comes to us about, gee, I want to use your product for this, and we know that's not a good fit, we're going to tell them, there's an application that you'd be better off using Hadoop or NoSQL, or something else. So what we found when looking at some of those products where they've added in columnar indexes is you get nowhere near the performance for queries, the support of the volume of data. You don't get anywhere near the compression that you can get with something like Infobright, and it actually makes things more complex rather than less complex, and we're all about making things simple. So we think, again, if your use case is machine-generated data analytics and you've got lots of data and you're looking for something that is a lower cost, simpler to use, simpler to implement solution, that's where we're a good fit.
Yes, excellent. Yeah, I would agree. I heard from one vendor, they were describing how they were doing the implementation of their index, and then I said, so how do you load data into it once you apply the index? It goes, well, you don't. And I was like, excuse me.
Right.
So yeah, I was with you that level of manipulation and then administration to get that level of performance probably would outweigh any of the gains that you would have gotten from that particular indexing strategy.
Yeah, and when we look at other products out there, I mean there are other products that can deliver the performance that you need for analytics and those sorts of things, and they're fine. A lot of other fine databases out there. We don't think anybody can deliver it though at the reduced level of cost and complexity and reduced administration that we can. So again, we really try and focus both in terms of when we enhance our product, is this staying in line with where we believe our value to be. Okay,
excellent. So Eric, I think at this point we've gone through all the questions that I would have, and I think it's time for us to start taking queries from the audience.
Yeah, we have a number of really good questions here, so thank you very much for sending those in. Folks, you still have time to send your questions in, so don't be shy. Here's a really good one right off the top here, Susan, I'll throw out to you. One of the attendees asks, is Infobright dependent now on Oracle patents due to the MySQL usage?
Well, Infobright has an OEM agreement with Oracle, so we have a license for the for MySQL, which is what we need for our Enterprise Edition product. So that is a long-term agreement, and it's certainly served us very well.
Okay, good. We got another specific question on one of the slides that you pushed. They referenced slide 11, and let me see. I think that's the one. And the question is, do the requirements explained here, are they satisfied better by private, public, or hybrid cloud solutions?
Well, I think that's a great question. And I think one of the interesting things, if you look at the growth around cloud and the growth around big data, is to date there hasn't been a great intersection of the two. And I'd be interested in John's take on this. And when you're talking about big data and this kind of application, there seem to be two challenges that are really preventing massive adoption of these in the cloud. The first, of course, has to do with security, which is always going to be an issue for data. But the second is, when I'm talking about massive amounts of data, how can I load it into the cloud fast enough when my requirement is for near real-time analysis? So I think that we will see more and more of this. And by the way, one of the real advantages that we have is this distributed load processor I mentioned. What it's doing up front, if you use that locally, so all your data is basically using this remote loader or this local loader to you, and then it's compressing that data, that instead of having to, sorry about that noise, instead of having to send a terabyte of data per hour up into the cloud, because it's compressed at an average of 20 to 1, you've got 1/20th of that amount of data to go into the cloud. So I think we'll start to see more and more of this. But today, I just don't think beyond things like proof of concepts and small projects with small amount of data, we're just not seeing a whole lot of big data in the cloud yet. And again, I'd turn that over to John to get his thoughts on that.
Yeah, John, do you want to comment?
Yeah, and Susan, as we talked about a little bit in the preamble, when you start talking about cloud and big data, unless the data is generated in the cloud or co-located near where your cloud resources are, I would say it'd be very difficult to move that amount of data around the planet effectively. Unless, of course, you were instituting some type of technology or technique, as you just talked about. How do you compress it down so you're moving the least amount of data possible, moving that around? But I would agree. I think that in the near term for big data, EMA is seeing from our research that you're going to see private cloud implementations where you can utilize the burst capacities that go along with private cloud and the provisioning capabilities that go along with private cloud. But before we start getting up into hybrid or public cloud implementations, we're going to have to see either best practices established in those techniques for data transfer, or increases in the availability of bandwidth to get information from where the data is generated to where it is being analyzed.
Okay, good. And we got a lot of really good questions here, so let's just keep diving right in. One of the attendees wants to know, what if I need to combine machine-generated data with standard OLTP-generated data to satisfy user query needs? How would you deal with that?
Yeah, I mean, again, we've designed a database that's really good at machine-generated data, but the important thing is not that it's machine-generated, it's the characteristics of that. Again, the fact that this is typically data that's coming in at high rates and it isn't changing. If lots and lots of people are using Infobright for analyzing data that has been transactional, but they're not using it for those transactions, if you will.
Okay, good. And let's see. So we've got a whole bunch of good ones here. One of the attendees wants to know, are any EHR vendors using embedded analytics as a service to their healthcare providers? So electronic health record, that kind of thing.
Thank you. Thank you for that. We have a few. We do have a few hospitals and insurance companies as customers. So I certainly wouldn't say that it is, one of our top three or four use cases that we're involved with, but we are starting to see some of it.
So Eric, from my perspective, I'd say that Columnar is a great way to do analytics on EHRs, because at the moment, we're probably thinking about EHRs in terms of admissions, in terms of patient, in terms of this. But where a lot of the power is going to come from electronic health medical records is going to be when you turn that around and you start looking at it from a clinician perspective, anonymize it and start saying, what can we see from these perspectives? And they're going to not look at in terms of room or bed or billing. They're going to look at it in terms of demographics and some of those other pieces. And that shows that flexibility of not setting the semantic layer, if you will, on a particular data set before you start analyzing it. I would say that some of the security concerns that we've talked about here are probably going to be some of those overriding ones, and as soon as we get over those pieces and standardize, and I think the law goes into effect either in 2013 or 2014, we'll probably see a lot more traction in that particular marketplace.
Yeah, right. Of course, assuming it doesn't get overturned. We're all waiting to hear
I think the EHR part is pretty benign, and it shouldn't have a problem with that.
Yeah, there you go. Okay, good. Okay, so here's another very specific question, but I think it does offer some good perspective here. One of the attendees wants to know about how summaries are created when updates are happening. What is the lockdown strategy?
Right. Well, first of all, we support query while loading. So as data is coming in, you can still query against the database. But again, as I said, it is really not intended to be used if there are constant, high volume of updates or deletes going against a database. Then a columnar database is typically not really your best option. And there are other things that would make a lot more sense.
Okay, yeah, that's a good point. Horses for courses, right?
Yep, absolutely.
You have to know what you're using something for. So here's another good question. One of the attendees wants to know if embedded analytics could be harnessed to a predictive analytics engine in order to develop, refine, and test a predictive model.
It certainly sounds like something that makes sense to me. Absolutely.
Yeah, and I would echo Susan's comments that when you look at the result sets that come out of a technology like Infobright, they would have no problem going right into a predictive engine or being operated upon with Infobright being the engine behind it.
Okay, good. And here's another specific question about the knowledge grid and the knowledge packs. If I understand it correctly, when a query is made, what happens is first the engine will look to the knowledge grid to see if it can satisfy that query without uncompressing the data and going to a more granular level. But if it cannot, that's when it actually goes and uncompresses a particular pack. Is that right? And then gives a more detailed view?
Yeah, that's sort of right. It's an iterative process, so it parses that query into its respective parts, and it continues to iterate over the information in the knowledge grid until it actually has to go look at the data packs. And the whole goal is to look at as few data packs as possible. Now, the way that works is that what the engine is doing is using the information in the knowledge grid, it's dividing, if you will, the data on the database or these data packs into things where all information matches, no information matches the query, or only some does. And the only time it actually needs to go get the data and decompress the data pack is if it's that mid case, that suspect case, where it actually has to go in and look at the data to answer the query. So again, the whole goal in iterative fashion is to continue to pass over this query through the knowledge grid and continue to eliminate data packs from consideration. But when it does need to go get the data, yes, it'll decompress it, it'll bring it back, and use that to resolve the query.
Gotcha. Okay, good. And here's another really good specific question. It reminds me of something that I studied a number of years ago. One of the attendees asks, how is faster data loading or modification achieved since it is a columnar database? I recall that was one of the arguments against columnar a number of years ago, that namely most data that you're loading into a columnar database is in a relational database or a row-based database rather, and so there is that sort of lag time. But has that been solved? Can you kind of speak to that a bit?
Well, I mean, again, if you look at really what our how it works for us is this idea about you can use this distributed load processor to basically offload the work off the database. So all of that upfront compression, creation of the knowledge, the data packs, the knowledge nodes, and all ever is done remotely, and then you're basically just appending the data into the database itself. So trying to offload that and not have constant updates going on while you're running queries against the database, if I understand the question correctly.
Okay, that's fine. Okay, so I think, John, this next question is for you, talking about this concept of pushing analytics out to the edge. And I have a question myself on that, which I think it's a very interesting concept, and I think it's frankly an unavoidable trend, just based upon what's happening out there in the real world. One of the attendees writes, do you mean to say get the data to the center, compute summaries at every higher node, and pass back the relevant summary into the lower node so analysis can be done locally? Does that make sense?
Yeah, and what I think it's probably going to, the real answer is going to be, so I won't answer that specific question, is you're going to see summaries of the data or the detail move to the center. But you're going to see actions or the analysis that's going to happen out on the edge. So you might have, over the course of time, the data move to the center, new models being created, new pieces of information being created, and that information being pushed back out. But you might see that on the edge, you're going to see people go, if I've done these particular actions, which of my choices that I have that make it best for me to either make an offering, do some type of logistical optimization, things of that nature. So it's very similar to what you're seeing with some of the web optimization that Susan has talked about today, is where they're not trying to boil the entire ocean, they're trying to boil their particular piece of the ocean, and then when they go back and they go, okay, instead of looking at 1,000 options, we look at the 5 or 10 that are best for that particular node at that particular time and make a choice at that time. But you're doing those analytics farther and farther away from the center. You might be doing the historical stuff at the center, but you're doing the real-time actions out on the edges.
Interesting. And I would imagine that there are going to be some issues around data governance when you're doing that kind of analysis at the end, but I'm guessing that for some of those use cases, governance is not that big of an issue, right?
Well, when you're talking about standardized data information, yeah, the choice is going to be in terms of the governance of what are the models or what are the decisions you're trying to act upon as opposed to the data itself. So it's going to be a higher level of governance, but you are correct. Governance will be a piece of that, and it'll be important to take that into consideration.
Gotcha. Okay, good. And let me throw, I guess, just one more out over here. Thank you for all these questions, folks. And if any question you ask is not answered by me, feel free to get in touch with me or directly in touch with the speakers today. I'm sure they will be glad to clarify anything. One of the attendees writes that according to Gartner, Europe is roughly 2 years behind the U.S. in terms of cloud adoption. Is that the same for Columnar Database usage? What do you think about that?
No, I don't believe so. I mean, I think that if you look at, again, Columnar databases have been around for a while. Actually, it goes back to, I did a little history and learned that it actually went back to, I don't know if it was IBM or whatever, but back in the 60s, somebody in a mainframe, really did the first Columnar database. But of course, Sybase really popularized it with IQ quite a few years ago now. So, we certainly see lots of traction in Europe. We see lots of people using it in Europe. Again, Middle East and Asia is really coming up as well. So I doubt it would be 2 years behind.
Okay, good. Well, folks, we do archive all these webcasts for later viewing. You can go to InsideAnalysis.com, look under the webcast tab. You can find links to all the briefing rooms that we've done, all 53 of them now. So a very big thank you to all of you for these great questions, and a big thank you to John Myers of EMA and, of course, to Susan from Infobright. This does conclude our webcast, but thank you so much for your time and attention. And as I mentioned, hop online to databaserevolution.com, and you can check out the 40-page report that we just completed earlier this week, I think, or last week. It's an excellent report, a very, very detailed look at the expanding market of database technology, a lot of these new SQL and NoSQL and other technologies like that. They are very interesting. They have very compelling use cases. So definitely check it out, folks, databaserevolution.com. With that, we'll close our event. Panelists, stick around for just a minute, and we'll have a debrief. Thanks again, folks. Take care. Bye-bye.